SpaceX just did something insane. They're deliberately destroying a $60 million rocket. On purpose, Ship 35 and Booster 14 are rolling to the pad right now. But here's the shocking part. Elon wants them to explode. One engine will shut down mid-flight. A 100-ton booster will crash into the ocean. The FAA doubled their danger zone to 1,600 miles. But why? The truth behind this controlled destruction will change everything you think you know about space travel. Let's dive right in. Here's what happened on May 25th that sent shockwaves through the space industry. At exactly noon, Ship 35 rolled out to Launch Pad A, but this wasn't your typical rollout. Hidden inside the payload bay, 8 dummy Starlink satellites, weight simulators that would test something SpaceX had never successfully done before. 2 hours later, Booster 14 joined its partner. But here's where things get weird. B-14 had been sitting on that launch mount for a full 10 hours before Ship 35 even arrived. Why the rush? Because this booster carries a secret that could change everything. This is the first time in SpaceX history they're attempting to reuse a super heavy booster. Think about that for a second. Every previous flight used a brand new $60 million booster that was essentially thrown away. But B-14, it's already flown before and survived. But why would SpaceX risk destroying something so valuable? The answer lies in a number that will shock you: $500 million. That's how much liability insurance SpaceX had to buy for this single flight. To put that in perspective, most Starship flights require around 100 to 200 million in coverage. The insurance companies know something. We're just beginning to understand. This isn't just a test flight. It's a deliberate stress test designed to break both vehicles at their absolute limits. Here's the terrifying part. During landing, SpaceX will intentionally shut down one of B-14's 3 center engines. Picture this: a 233-foot-tall rocket, weighing 100 tons, screaming toward the Gulf of Mexico at thousands of miles per hour. And they're going to turn off a critical engine just to see what happens. If that backup engine from the inner ring fails to ignite, B-14 will slam into the ocean at terminal velocity. The impact alone could rupture fuel tanks from the inside, and just one tiny spark from the mangled metal could trigger a massive fireball, visible for miles. Remember that 1,600 nautical mile no-fly zone? Here's what the mainstream media isn't telling you. That zone stretches from Texas all the way past the Florida Strait, covering the Bahamas and Turks and Caicos Islands. It's almost double the size of Flight 8's danger zone. But that's not the scary part. The FAA also issued a separate notice covering the Indian Ocean, a massive elliptical zone stretching from southeast of South Africa to southwest of Australia. Why? Because if Ship 35 makes it to orbit and something goes wrong during re-entry, debris could scatter across thousands of miles of ocean. The restricted time frame runs from May 28th to June 3rd, with daily blackout periods from 12:05 a.m. to 3:05 a.m. That's when hundreds of commercial flights will have to reroute, costing airlines millions in fuel and delays. What kind of test requires this level of global coordination? The answer will change how you think about space exploration forever. While everyone was focused on the dramatic rollout, SpaceX engineers were making modifications to both vehicles that tell a very different story. On Ship 35, they removed dozens of heat shield tiles, not to replace them, but to deliberately expose the bare metal underneath to the intense heat of re-entry. In place of some tiles, they installed experimental metallic plates, including one with active cooling. But here's the part that should terrify you. They're testing these materials at the absolute worst possible time. During max aerodynamic pressure, when the forces trying to tear the ship apart are at their peak. Why would they do this? Because SpaceX knows that eventually, tiles will fail, heat shields will crack, and when that happens during a crewed mission to Mars, astronauts' lives will depend on these backup systems working perfectly. On both sides of the ship, they added mock attachment points to simulate the stress of carrying massive payloads. Even the tile seams were smoothed and beveled to reduce hot spots that nearly destroyed Ship 29 during Flight 6. But there's something else SpaceX isn't talking about. The harmonic oscillation problem that has plagued every recent flight. This isn't just an engine issue. It's a fundamental flaw in how the entire spacecraft structure responds to Raptor engine vibrations. During Flights 7 and 8, these oscillations damaged fuel lines, caused catastrophic leaks, and ultimately led to both ships exploding before they could deploy their payloads. SpaceX claims they've fixed it, but here's the truth. Nobody knows for sure until Ship 35 fires its engines at full power. The higher the ship climbs, the more violent these oscillations become. And if they haven't truly solved the problem, the explosion won't just destroy Ship 35, it could scatter debris across multiple countries, potentially hitting populated areas. This is why Flight 9 isn't just dangerous. It's a calculated risk that could either prove Starship is ready for human flight or ground the entire program for months. Let's talk about what makes B-14 special. Hidden in its engine bay are modifications that represent the biggest leap forward in rocket reusability since the Falcon 9. SpaceX has blocked specific vent holes in the engine section, using the rocket's own thrust to control exactly how it flips during descent. Until now, this flip maneuver was essentially random. The booster had to burn extra fuel to correct its orientation, limiting how much payload could reach orbit. But with controlled flipping, every kilogram of fuel saved translates directly to more cargo capacity. They're also testing a new landing profile, where B-14 will fly at a much higher angle of attack. This creates more atmospheric drag, slowing the descent and reducing fuel consumption during the crucial landing burn. It's brilliant engineering, if it works. But here's the catch. If any part of this new system fails, B-14 won't just crash, it will create a debris field, spanning several miles of ocean. At 100 tons moving at terminal velocity, the impact energy is equivalent to a small explosive device. Here's where the story takes an unexpected turn. Each NASA SLS rocket costs over $2 billion to build and can only be used once. Starship's entire development program has cost SpaceX less than half that amount, and they're building rockets that can fly dozens of times. If B-14 successfully demonstrates zero-touch reflight capability, meaning no major maintenance between missions, SpaceX could ramp up to 25 flights this year alone. Within 5 years, they're targeting 100 launches annually. That's more than the rest of the world combined. But there's a deeper game being played here. Every successful Starship flight brings NASA's Artemis 3 mission one step closer to reality. We're talking about the first human lunar landing in over 50 years, and it all depends on Starship, proving it can safely transport astronauts. The pressure is immense. Congress has already approved billions in funding. International partners have committed resources, and the Chinese space program is breathing down NASA's neck with their own lunar ambitions. What SpaceX hasn't publicly disclosed is that Flight 9 is actually testing 2 critical systems simultaneously. Yes, they're deploying dummy Starlink satellites, but those 8 payloads, they're also testing the exact deployment mechanisms that will be used for orbital refueling. Here's why this matters. Artemis 3 requires multiple Starship launches to transfer fuel in orbit. The mission profile calls for one Starship to serve as a fuel depot, while another acts as the human landing system. If the docking and fuel transfer mechanisms fail, astronauts could be stranded in lunar orbit with no way home. Flight 9's simple satellite deployment is actually a dress rehearsal for the most complex orbital operations ever attempted. Each dummy satellite weighs exactly the same as a fuel transfer module, and the deployment timing, it mimics the precise choreography needed for refueling operations. The stakes couldn't be higher. A single failure in these systems could delay Artemis 3 by years and cost taxpayers billions in additional development costs. As Ship 35 screams back through Earth's atmosphere at 17,000 miles per hour, It will face temperatures exceeding 2,700 degrees Fahrenheit. But remember those missing heat shield tiles? They're not accidents. They're deliberate weak points, designed to test how the ship responds to thermal stress. SpaceX engineers want to see exactly what happens when the protective barrier fails. Will the underlying structure hold? Can the backup metallic plates withstand the heat? Or will Ship 35 disintegrate in a spectacular fireball over the Indian Ocean? This is where the real danger lies. Unlike previous flights that followed relatively safe trajectories, Ship 35's re-entry path takes it over some of the busiest shipping lanes in the world. If large pieces of debris survive the breakup, they could pose a serious threat to vessels below. The flight profile is intentionally designed to push both the thermal protection system and structural limits simultaneously. It's like testing a race car's brakes and engine at the same time while driving at maximum speed. Behind all the technical complexity and calculated risks lies a simple truth. SpaceX is rewriting the rules of space travel in real time. Every failure teaches them something that traditional aerospace companies spent decades and billions trying to learn. But here's what makes Flight 9 different from every previous test. For the first time, the success or failure of this mission will directly impact humanity's return to the moon. NASA has already committed to using Starship as the human landing system for Artemis 3. If Ship 35 and B-14 prove that rapid reusability is possible, we're looking at a future where space travel becomes as routine as commercial aviation. But if critical systems fail, it could set back human space exploration by a generation. The question isn't whether SpaceX will learn something valuable from Flight 9. They always do. The question is whether what they learn will accelerate or delay our species becoming a multi-planetary civilization. Right now, as you're watching this video, Ship 35 and Booster 14 are sitting on that launch pad, loaded with fuel, ready to make history. In less than 48 hours, we'll know if SpaceX's bold gamble pays off. Will B-14 survive its controlled destruction test? Will Ship 35's heat shield modifications work? Or will it burn up in a ball of fire? The engineers at Starbase have run thousands of simulations. They've stress-tested every component. They've calculated every possible failure mode. But here's the thing about pushing the boundaries of what's possible. Sometimes the universe has other plans, and that answer lies just days away. As Ship 35 and Booster 14 prepare for the most consequential flight in SpaceX history. Because this isn't just about rockets anymore. It's about whether humanity is ready to take the next giant leap into the cosmos. So here we are, watching SpaceX deliberately risk destroying a $60 million rocket to push the boundaries of what's possible. This isn't just about Flight 9 anymore. It's about proving that controlled destruction can lead to revolutionary breakthroughs. Every failure SpaceX engineers brings us one step closer to making humanity a spacefaring civilization. In the next few days, we'll witness either the most spectacular success or the most educational explosion in SpaceX history. Either way, we learn something that changes everything. What happens next depends on more than just engineering. It depends on whether we're ready to embrace the risks that come with reaching for the stars. Here at Space Corps, we'll be covering every moment of Flight 9 live, breaking down what it means for Artemis 3, Mars missions, and the future of space exploration. If you want the inside story on what really happens when rockets push their limits, hit that subscribe button and ring the notification bell, because this is just the beginning of something much bigger. Here's what I want to know. Do you think SpaceX's controlled destruction approach is genius or reckless? Drop your thoughts in the comments below. And more importantly, are we moving too fast or not fast enough toward becoming a multi-planetary species? The countdown has already begun, and Space Corps will be there for every explosive moment.